30 milliamp ground fault circuit interrupter, or GFCI, is not appropriate for use with a fountain located in a lake. The primary reason is the increased risk of nuisance tripping and the potential for not providing adequate protection in such an environment. Standard GFCI devices are designed to trip at a ground fault current of 5 mA plus or minus 1 mA as mandated by Underwriters Laboratories, or ALL, Standard 943. This threshold is set to protect individuals from dangerous electrical shocks. When a ground fault occurs, meaning that electrical current is leaking to ground, the GFCI detects this imbalance and quickly cuts off the power to the circuit. This rapid response is critical in preventing electrocution. In the context of a lake fountain, several factors can contribute to ground faults and therefore nuisance tripping. Firstly, the very nature of a fountain involves constant contact with water, which is a conductive medium. Any minor insulation breakdown in the pump motor, wiring, or underwater lighting fixtures can create a path for current to leak into the water. Secondly, the grounding system itself can be compromised. A proper grounding system is essential for directing fault currents back to the source, allowing the GFCI to detect the imbalance. However, in a lake environment, achieving a reliable ground connection can be challenging due to varying soil conditions, the presence of minerals, and the potential for corrosion of grounding electrodes. Thirdly, the presence of aquatic life and organic matter in the lake can further exacerbate the problem. These elements can create conductive pathways and increase the likelihood of ground faults. Given these factors, a 30 mA GFCI is likely to trip frequently and unnecessarily. While it might seem that a higher trip threshold would solve the nuisance tripping issue, it actually compromises safety. A 30 mA GFCI allows a significantly higher level of leakage current before tripping, which increases the risk of electrical shock. If a person were to come into contact with the water while a ground fault is present, they could experience a dangerous or even lethal shock before the GFCI interrupts the circuit. Therefore, using a standard 5 mA GFCI is critical for ensuring adequate protection. When dealing with electrical installations near water, it is essential to adhere to specific safety codes and regulations. The National Electrical Code, or NEC, provides detailed guidelines for electrical systems in and around bodies of water. These guidelines address issues such as grounding, bonding, wiring methods, and the use of ground fault protection. It's imperative to consult with a qualified electrician who is familiar with these codes and can ensure that the installation meets all safety requirements. Furthermore, consider these additional safety measures when dealing with electrical equipment at a lake fountain. Firstly, use submersible pumps and lighting fixtures that are specifically designed and rated for underwater use. These devices are typically constructed with robust insulation and sealing to prevent water ingress and minimize the risk of ground faults. Secondly, regularly inspect and maintain all electrical equipment looking for signs of damage, corrosion, or insulation breakdown. Promptly repair or replace any faulty equipment to prevent potential hazards. Thirdly, implement a comprehensive grounding and bonding system. This system should include a dedicated grounding electrode driven into the earth near the lake, as well as bonding conductors connecting all metallic parts of the fountain and electrical equipment. Bonding ensures that all metallic surfaces are at the same electrical potential, reducing the risk of shock. Fourthly, consider using an isolation transformer to isolate the electrical circuit from the main power supply. An isolation transformer provides a high degree of electrical isolation, preventing ground faults from propagating back to the main power source. Fifthly, install warning signs around the fountain to alert people to the potential electrical hazards. These signs should clearly state that the water may be energized and that swimming or wading near the fountain is prohibited. Sixthly, implement a regular testing and maintenance program for the GFCI devices. GFCI devices should be tested monthly to ensure that they are functioning properly. This can be done by pressing the test button on the GFCI receptacle. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. Seventhly, consider the use of an equipment leakage circuit interrupter, or ELSI, instead of a GFCI. LSIs are designed to detect smaller ground fault currents than standard GFCIs, typically in the range of 10 to 30 milliamps. LSIs are often used in applications where nuisance tripping is a concern, but a high level of ground fault protection is still required. Eighthly, ensure that all wiring and connections are properly installed and protected. Use waterproof connectors and conduits to prevent water from entering the electrical system. Also, ensure that all wiring is properly supported and protected from physical damage. Ninthly, provide adequate overcurrent protection for the circuit. This can be done by installing a circuit breaker or fuse in the electrical panel. The overcurrent protection device should be sized appropriately for the circuit and the equipment being protected. Tenthly, consider the use of a remote monitoring system to monitor the electrical system for ground faults and other problems. A remote monitoring system can provide early warning of potential problems, allowing you to take corrective action before a serious hazard develops. 11thly, ensure that all work on the electrical system is performed by a qualified electrician. Working with electricity can be dangerous, and it is important to have the proper training and experience to do the job safely. A qualified electrician will be able to identify potential hazards and take the necessary precautions to prevent accidents. 12thly, keep a detailed record of all electrical work performed on the fountain. This record should include the date of the work, the name of the electrician who performed the work, and a description of the work performed. This record can be helpful for troubleshooting problems and ensuring that the electrical system is properly maintained. 13thly, review the electrical system on a regular basis to identify any potential problems. This review should include a visual inspection of the wiring, connections, and equipment, as well as testing of the GFCI devices. 14thly, be aware of the signs of electrical problems. These signs can include flickering lights, tripped circuit breakers, and shocks when touching metal objects. If you notice any of these signs, immediately turn off the power to the fountain and call a qualified electrician. 15thly, educate yourself and others about electrical safety. Understanding the dangers of electricity and how to prevent accidents is essential for protecting yourself and others. You can find information about electrical safety from a variety of sources, including the National Electrical Code, the Electrical Safety Foundation International, and your local utility company. 16thly, always err on the side of caution when working with electricity. If you are not sure how to do something safely, do not attempt it. Call a qualified electrician for assistance. 17thly, never work on electrical equipment while standing in water or on a wet surface. Water is a conductor of electricity, and standing in water can increase your risk of electrical shock. 18thly, use insulated tools when working on electrical equipment. Insulated tools can help to protect you from electrical shock. 19thly, disconnect the power to the fountain before performing any maintenance or repairs. This will help to prevent accidental electrocution. 20thly, after completing any electrical work, test the GFCI devices to ensure that they are functioning properly. This will help to ensure that the electrical system is safe to use. By following these guidelines and working with qualified professionals, the electrical safety of the lake fountain can be maintained and the risk of electrical shock can be minimized. Remember that electrical safety is paramount, and any shortcuts or compromises can have serious consequences.